Today should be pretty simple if you know all of the parent functions. And I believe we don't have to do y equals x. That's nice. Okay. So the parent functions are, well, there are lots of parent functions, but the ones we're going to use, y equals x squared, y equals x to the third, y equals 1 over x, and y equals the square root of x. What else do they use? Absolute value of x and third root of x. Yeah. Absolute value of x. I'm running out of room. And y equals the third root of x. Okay. So x squared, you guys know this one. Looks like that. X to the third, looks like that. 1 over x, you are not as familiar with, but it looks like this. It never hits any of the two axes, either of the two axes. Okay. This one is the square root of x. This one is the absolute value of x. And then the third root of x is exactly the same as x to the third, only it's sideways. So it kind of does this. It's kind of like a square root graph, but it's on both sides, and it actually has the same shape as the x to the third graph. It's just been reflected. Okay. So if those are all of my parent functions, let's do some transformations. Y equals 3 times x plus 1 squared minus 2. So I know that I'm going to be using this graph, and I have to do the transformations from the inside out. So inside I have x plus 1, which moves the graph left 1, and then I have a 3 on the outside, which changes the y values. What happens when you multiply the y values by 3? They get taller, and the minus 2 moves it down 2. So left 1, down 2, and it's 3 times taller. So it would look something like that. Everybody understand that? Okay. What about y equals the square root of negative x plus 1? What does making the x negative do to the graph? Flips it. And remember, it's changing the x's. So what happens when I flip the x's? It reflects across the y-axis. All the positive x's become negative x's, and the negative x's become positive x's. Okay, and then I add 1. So my original graph is over here. I flip it over here, and then I go up 1. So it looks like this. Going all right with that? Okay. What about y equals 3x plus 1? This one's a little bit tricky. Okay. I'm going to change it so it says 3 times 1 over x plus 1. Does that make sense? So my original graph is this, 1 over x. And then when I add 1 to the x, it's going to move left. And then the 3 is going to make it taller. So the original graph looks like this. Actually, let's do it this way. So the original graph looks something like this. And I'm going to move that graph left 1. Okay. Then I need to make it taller, which means everything moves 3 times further from the x-axis. So this point is going to move up to there, and this point is going to move up to there, and what we have is the same basic graph, but it stays a little bit further away. That's a terrible picture. Let's try that again. Now, instead of hugging the axis as much, it kind of goes like that. That one's hard to draw. Okay. What if I had y equals the absolute value of 4x minus 3? What does multiplying the x by 4 do? So we're changing the x's, and every time you change the x's, it's backwards. So multiplying the x's by 4, actually 4 times skinnier, because the x's move left and right. So we have the normal absolute value graph, and we're going to make it 4 times skinnier. And then we're going to subtract 3. So if the original graph looked something like this, then the new graph is going to be much skinnier, and it's going to go down 3, like that. Okay. What about this? This is number 60. 2 minus 1 over 1 minus x. This one is really complicated. Huh. Well, what do you notice? That one is actually left 1. Okay. And what does that do? Flips it over the y-axis because it changes the x's. So we're going to flip it this way. Okay. And then what does this do? Flips it upside down. And then what does this do? Adds 2. Does that make sense? And this is definitely as hard as they get. So my original graph looks like this. We have to flip it left and right. Oh, seriously? No, that's not going to work. Anyway, so I have to flip it left and right, so I get this one and this one. Then I have to move that to the left 1, and then I have to flip it upside down. So I end up with this and this, and then I have to add 2. So I would lift it up 2, which is kind of hard to see, but that's the final result. Like that. All right. I think you guys should be able to do this. Did I cover the whole assignment? How far are you supposed to go? 61. Yep, we're good. Good luck.